faint hint of the background hum of the universe detected by scientists. Ever since scientists made the first detection of gravitational waves from a pair of colliding black holes back in 2015, evidence has been growing that the universe ought to be full of them. Every massive event, every black hole or neutron star merger, every supernova should have sent gravitational waves ringing out across space-time. The combined effect of all these waves would be to create a faint background hum, and this hum would permeate the entire universe. This gravitational wave background is predicted to be weak and very hard to detect. But even so, a year ago, scientists with the International Nanograv collaboration say they may have done just that. And now from the International Pulsar Timing Array, IPTA Consortium, new evidence that we may have detected the hum has emerged, and if this is confirmed, this will be a very big deal. This is a very exciting signal, says astrophysicist C1 Chen of the Observatory of Paris and CNRS in France. He says, although we do not have definite evidence yet, we may be beginning to detect a background of gravitational waves. As we explained last year, he says, the signal comes from observations of a type of a dead star called a pulsar. These are neutron stars that are oriented in such a way that they flash beams of radio waves from their poles as they rotate at millisecond speeds compared to a kitchen blender. And these flashes are incredibly precisely timed. It means that pulsars are possibly the most useful stars in the universe. Variations in their timing could be utilized for navigation, for probing the interstellar medium and studying gravity. Since the discovery of gravitational waves, astronomers have been using them to look for these as well. And that's because gravitational waves warp space-time as they ripple through, which theoretically should change ever so slightly. Finally, support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box. Gravitational waves this way warp space-time as they ripple through, which theoretically should change slightly. The timing of the radio pulses given out by the pulsars as space-time between us and them stretches and contracts. A single pulsar would not be able to tell us much, but if these timing variations are observed in a number of pulsars, that could indicate the presence of gravitational waves. This is called a pulsar timing array. The team's dataset is based on observations of 65 millisecond pulsars, the timing of which displayed characteristics consistent with what we'd expect from a gravitational wave background. It's not solid evidence, not yet anyway, but it's a step closer to the evidence, and what scientists really need to see is a particular signal in a pair of pulsars, the strength of which depends on their spatial distance in the sky. We have not yet seen that because the signal is too weak, but the signal we have seen is what we'd expect to see first. The first hint of a gravitational wave background would be a signal that, like seen in the International Pulsar Timing Array Data Release 2, said astrophysicist Bal Chandra Joshi of the National Center for Radio Astrophysics in India. Explaining then, with more data, the signal would become more significant and will show spatial correlations, at which point we will know that it is a gravitational wave background. We are very much looking forward to contributing several years of new data to the IPTA for the first time to help achieve the gravitational wave background detection, he said. Other causes of the signal also need to be ruled out. We are also looking into what else the signal could be, says astrophysicist Boris Goncharev of the Gran Sasso Science Institute in Italy. He said, for example, perhaps it could result from noise that is present in individual pulsars, data that may have been improperly modeled in our analysis. And that means there's a lot more science to do before we can definitely claim that the gravitational wave background has been detected, but with the evidence to hand, it's reasonable to start getting a little bit excited. And that's because if we have detected the gravitational wave background, the likeliest source is from collisions between some of the most massive objects in the universe, that is, supermassive black holes. This means that the signal could help resolve such conundrums as the final parsec problem, which poses that supermassive black holes might not be able to merge and help us better understand galactic evolution and growth. The detection of gravitational waves from a population of massive black hole binaries or from another cosmic source will give us unprecedented insights into how galaxies form and grow, or cosmological processes take place in the infinite universe, says astrophysicist Alberto Vecchio of University of Birmingham in the UK. He says, a major international effort of the scale of IPTA is needed to reach this goal, and the next few years could bring us a golden age for these explorations of the universe. The research of this team has been published in monthly notices of the Royal Astronomical Society, and this is on Science Alert. Please leave your comments. Thank you for your support.